Welcome to part 4 of my LinuxCNC HAL tutorial. In this one, we're going to build off the external relay triggering we did in part 3 by giving ourselves a button in PyVCP that will also let us control the relay. So what is PyVCP? Well, it's a virtual control panel that lets you add software buttons to Axis, the standard GUI here in LinuxCNC. So all the stuff on the left comes built in as part of the GUI, and the stuff on the right are bits I added with PyVCP. There's a few LED indicators, some text boxes where you can enter values, a number readout, the checkbox will be added in this video, and then you can also have buttons, dials, bar charts, other things like that. You know, nothing too crazy, but things that still do add a good bit of value and functionality to the GUI. In fact, what you're seeing here is what I currently use on my CNC plasma table. So in the last video, we were using the MDI console and the M62, 63, 64, and 65 G code commands to trigger that relay off and on. And that was switching a crosshairs set up on my plasma table that I use for aligning the work before I run a job. So now in this video, we're going to add this checkbox over here. So when you click this, it will also turn the relay off and on. Gives us another way of doing it. Now, all we're going to add in this video is this one bit here, and the other parts for the torch height control and ohmic sensing will come in future videos. So let me go and check out the code for this part. As I've mentioned in other videos, all these files of mine are kept in a Git repository, which makes it very easy to go through the full history of everything and see what was added, in which part of the tutorial, and what lines changed and what that built on up on this configuration. So what you're seeing now is for part 9. We're going to check out part 4 and keep on working from there. So there we go. And now if I relaunch Axis, we'll see all we have is the crosshairs. Baby steps, right? Now, PyVCP is nice to have for a few reasons. For one, good, reliable physical buttons are expensive and they require some setup. You have to make a mounting panel for them, actually install them, wire them up, and even then they take up I/O pins on your breakout board. So if you compare that to a few lines in your configuration files, it's pretty obvious which one's easier, right? Secondly, PyVCP does give you more options than a physical control panel in terms of readouts and things, right? Like a number readout is hard to make on a panel of your own. In PyVCP, it's a few lines of code, right? A dial readout, how are you going to hook up one of them on a physical panel? But in PyVCP, again, just a few lines of code. So overall, that also lets you do a lot more. And thirdly, PyVCP is meant to tie into HAL. So for what we're working on now, that's perfect. Really, the only limitation of PyVCP is that all it does is read and write HAL pins. It can't run external programs or run arbitrary code. You can't do keyboard shortcuts tied into buttons on your PyVCP panel, stuff like that. But for either setting values in HAL or reading them out to you so you can see what they are, it is absolutely fantastic. So I will mention there's another VCP called Glade VCP that you might want to look into if you need more than what PyVCP has to offer. For one, rather than only using text files to edit, you have a what you see is what you get editor, which is kind of nice. And if you know how to write Python, supposedly you can make the buttons in Glade VCP run arbitrary Python functions. Now, just mentioning this, I personally have no experience with Glade, so we're not going to cover that at all in this video beyond me mentioning the fact that it exists. So to set this up, the first thing we need to do is tell LinuxCNC where to look for our panel. And we do that in the INI file. So here in the display subsection, we have an option for PyVCP equals custompanel.xml. And that is the file that contains our panel definition. And this option was automatically inserted here for us by the step-conf wizard when you ran that way back when. Now, if you didn't check the option for that, all you have to do is come in here and just add it, PyVCP equals the name of your XML file. Obviously, if you pick a different name, put a different value, but that's all you got to do. One other thing this option does is it automatically loads the PyVCP component for us in our HAL. So you might remember from earlier videos, when you have a HAL component you want to use, you need to do a loadRT or a load user command to make that available in HAL. Well, having this PyVCP option here will do it automatically for us. And there are some special circumstances where you might not want to do that. Say if you want to have a standalone PyVCP panel. So rather than loading Axis and having a panel on the side, you want to have a standalone window that is just a PyVCP panel. In that case, you'd still use the loadusr PyVCP command, and then there you would give it the value of the XML file for your panel. But for like 99% of cases, just this little bit here is all you need, okay? And then a bit further down, as before, we need to tell LinuxCNC what HAL files to load, including the HAL file for our panel. So we have the main file made by the stepconf wizard way back when, the one we added last time for controlling the relay and the crosshairs, and then the postgui HAL file that stepconf also gave us more as a blank template. And this time we're going to put some real content in there. Again, the names here have all changed from what stepconf originally gave them, more so just for my own organizational purposes. And when you change those file names, again, you got to come in here and update them here so LinuxCNC knows where to look. The postgui HAL file is also a little bit special in that it runs after the GUI loads. There's a whole kind of process of how these different components get added to Linux as you boot up the whole CNC component and the real-time side of things. But since this is working with the GUI, you got to put it very last under the postgui HAL file option. One other thing I want to point out is this halui option right here. Again, we added this in an earlier video, and we're not going to touch it just yet, but it's similar enough to PyVCP that it does bear mentioning. So putting this in here, that will automatically load the halui component in your postgui HAL file. And what that gives you is just a whole slew of HAL pins, just dozens and dozens and dozens of pins that correspond to pretty much everything in the Axis GUI interface. So for example here, we have an output pin that tells you if the machine is on or not, and then 2 input pins you can write to if you want to turn the machine off and on from HAL. So these 3 here correspond to the status of this button in Axis, and then actually clicking it to turn the machine off and on. So you can think of it as halui controlling everything on the left side here, and PyVCP controlling everything on the right. And in that way, they're kind of similar. And the odds are, if you're using PyVCP, it's probably worth going ahead and just chucking this value, this option, in here as well. Next up, we have the XML file itself. So if you're not familiar with XML, the best way I can describe this is that it's similar to HTML on a website. So you open up a web page, you right-click, and you go to the View HTML option. And you'll see that just ungodly mess of shit in the background, that thing that makes the web page. XML is similar to that. But luckily, we're not building a full-blown web page. All we're doing is a simple panel for a CNC machine. So our XML will not be nearly as bad as doing a website. Okay? Now this file here, it describes one checkbox, or I guess a check button in LinuxCNC lingo. And we give this a name of laser-button. So later on in our HAL, we can go pyvcp.0.laser-button, and then that will give us an output HAL pin that will have the status of the checkbox. So if it's unchecked, that'd be a false or a 0, and if it's checked, that'd be true or a 1. And then we can use that value throughout the rest of our HAL. Now, if you don't give the PyVCP bit a name right here, then it will automatically assign a name, something like checkbutton.0 or whatever, but it's a little bit harder to use and harder to keep track of. So I do recommend giving each of your PyVCP widgets a name like this one here. Now, as for what the options are in terms of like check button or LEDs and that kind of stuff, there's a set list of them, but there's really too many to cover in one video. So for that, I recommend going to the documentation that's available under the menu here. And in those PDF docs, you can go through all the examples, find the one that's close to what you need, and then just kind of change it to, to suit, right? And you'll find those examples in section 9.1.6 and also 9.2. Now, because XML is kind of a bitch to edit, right? Like every tag you open here, like check button, has to be closed with a /check button later on. And it's annoying. So I want to show you another tool that'll make your life a little bit easier. And that's xmllint. It comes included with LinuxCNC, so you should just build the command line and run it just like this. xmllint, no out, and the name of the file. And if you get no output, then it's good. Right? That means you have no glaringly obvious errors in your XML file. So if we come back here and I make a mistake in it intentionally, like so, and save it, when I run xmllint again, it will yell at me because the tags don't match. And it kind of points it out and makes it easier for me to find where I messed up. Now, it won't catch every error. It's like, say if I were copy and pasting things, and I copy and pasted a typo like this, and it's halpin rather than halpin on both cases. Then when I run that, it says it's fine, right? Because it can't catch that I typoed that thing twice because it sees the thing match up and says, oh, it's good. But then when you go to run LinuxCNC, and you reload, yes, then it will yell at you, right? And then you go through the debug log here, and eventually you'll find a spot where it says, unknown thing, halpin, as opposed to halpin. So that's a bit slower way of finding errors. I recommend using xmllint just to speed up that process. But again, you got enough examples to work from, and as you build things out, you get it set eventually, and then you're basically good to go. And then we have our HAL, which I guess we'll look at first in the git diff mode here. Now, as I mentioned in the last video, having these crosshairs be triggered via G-code is a little bit silly, because by their nature, crosshairs are an alignment tool that you use to set the workpiece up prior to running a G-code program. And once the program's running, you never really need to turn those crosshairs off and on again in the middle of a run. But even still, we're not going to undo that work from last time and then add the checkbox. We're going to add that on top by using a or2 logic component. And that just makes it a bit more complicated, but also a better example then. And you at home might have something in mind for your CNC machine that you do want to run both ways. So looking at the HAL file for the laser, we can see what changes I made here. And key among them is removing this net command, which really was the focus of the whole last video, right? Hooking up motion.digitalout to parallel port pin 16. So that's gone now. And we replaced that with a few new lines of HAL. And at the bottom, the command to invert that one pin is still there because my relays need that just to trigger properly. So we're starting off with loading the or2 component. So let's look at the man page for that and see what exactly it gives us. So you've got two inputs, both bits, in 0 and in 1, and then one output, also a bit. So, bits are booleans, true, false, 0, 1, like that. And the output is going to be equal to true if either one of the inputs is true, or if both of them are true. And if both inputs are false, then the output is false. Now, if in 1 or in 2 is true, then true, right? Now this component, like most of them, is loaded real-time with the loadrt command, and we give it a number, count of how many that we need. Since we only need the one of them, we can omit this option, and it becomes available to us as or2.0, right? So loadrt, or2, then we have ort.0 just automatically. So if you want more of these, say you need like 3 or2 instances, you say loadrt or2, count equals 3, and then they're available under or2.0, or2.1, and or2.2. Now the names option here is if you're using HAL2pass, which is another option in your INI file. Basically lets you replace those .0, .1, .2 names with real letter-based names. So it could be easier to keep track of things. It's probably a wise thing to take advantage of, but I haven't gotten that far yet, and we're not going to worry about that for this this video series. You can read about that more on your own in the docs if you want. So for every instance of or2 that we bring in, we need to add the function for it to a thread. So over here we've got the addf to add the function, or2.0 to the servo thread. As I said in the last video, you usually have two threads, the base thread, which is very fast, and the servo thread, which is simply fast. Not very fast, but still fast. And the motion planner and step gen, step pulse generator run in the base thread, and basically everything else can run in the servo thread. For me, my servo thread runs at a 1 millisecond interval. So 1,000 times a second is still plenty fast for basically everything. Now that we have the or2 component here, we basically take this old init command and we split it up into two. So now we're taking motion digital out and we're feeding that to 1/2 of the or2 input. So or2.0.in0. And that's given a new signal name now of laser-G code as opposed to simply laser. So in the PyVCP bit of HAL, we can distinguish this more easily from laser-PyVCP, right? And then that output from the OR, now we're calling that signal laser and still feeding that into parallel port pin 16. So you can see how we kind of removed this one net command and then spliced it in with the OR2. Now you might notice that PyVCP is not being referenced here at all. And that's because it comes later on in the postgui HAL file. I guess the order of HAL commands matters, but maybe not in the way you'd think, right? You have to load a component before you can use it, and you have to add it to a thread before you can use it. But beyond that, it's kind of like all bets are off. So the PyVCP pins don't get loaded until the postgui HAL file. So we save that part for hooking up that pin to the OR2 until that file. I think the only other restriction is that you can only load RT a component once. So for all of the OR2s you want to use in all of your HAL files, you need to say load RT count equals whatever right here, right now. So if I have another HAL file later on and it also needs an OR2, I need to include that in the count the first time I load our OR2. The HAL 2-pass option does have some workarounds for that, actually, but again, look into the docs for that if you want more information on that option. And then we have the HAL file for PyVCP over here. Now there's a comment and a set signal command in this file, but neither of them have any effect, so we just throw them out and replace them with the one new net command that really matters. This one where we hook up the PyVCP laser pin to or2.0.in1. And we give that signal a name of laser button. So we can see that HAL pin name from the XML file. I guess, yeah, you can see it right down here. This laser button now becomes pyvcp.laserbutton, and we feed that into the other half of the OR2. So now either one of these two things will trigger that parallel port pin. Now if things don't work as you expect, you can always load up the GUI and then an instance of halmeter and do some debugging. I'm pretty sure I mentioned this in one of the other videos, but we'll see what comes through in the editing, right? So halmeter is a tool that gives you access to check all the pins, all the signals, and all the parameters in your running instance of LinuxCNC. So I guess over here somewhere, yeah, we got one for the laser. So if I hit the crosshairs now, that will turn true. If I check it, it turns false. The laser button one also matches, right? And then the laser G code does not change when I hit this. And I guess I can't turn in the MDI command right now because the machine's turned off. But you can see how this is very useful for debugging. And if you have any gross errors in your HAL as well, then LinuxCNC will just fail to start and will give you a error message like I showed before when you gave it a bad custompanel.xml file. With the way we wrote this, either the G code or the checkbox is enough to turn on the crosshairs. But at the same time, you need to have them both off to turn it off again, right? And like you can't use the G code to turn it on and then turn it off with a checkbox. I mean, like, you probably could figure it out, but it's got to be some awful, convoluted, just nasty thing in HAL that I'm not going to worry about because that's too much. But even still, we can think of some better ways to kind of prototype this that might make it work a little bit better, right? So I know there's a MUX2 component in HAL as well. So let's look at that one and see how that differs from OR2. Now MUX2 is similar in that it takes two inputs, in .0 and .1, and has an output. But rather than taking the Boolean logic combination of the two inputs, it has a selection pin here. And it says if what, if cell is false, it just takes in 0, and if cell is true, it takes in 1. So rather than being like this or this, it's just grabbing one or the other depending on what this pin says. So if we had a way to tell whether a G-code program is running, we can make one or the other method of turning the crosshairs on inactive, right? So when a program's running, the checkbox is dead, and when a program's not running, the M codes for M62 to 65 are dead. Now, if I had to look for a way to see if a program is running or not, I would go to halui. It sounds like it fits, in there. And if we search for run in here, sure enough, there is a pin for halui.program is running. Cool. So kind of sketching this out, we could see in, let's see, 40. No. In this one here, in this laser HAL file, if we swapped out these OR2s for MUX2s, that'd get us partway there, but we still need to hook up the halui pin to the MUX2 selection pin. And that would have to happen in the postgui HAL file, because again, halui doesn't get loaded until that postgui part. So in here somewhere, you'd have, I guess, like a net command, running program, and that would be between halui.program.is running to the mux2.0.cell, right? And not exactly right. Now, why is that not exactly right? Well, because mux2.cell picks in 0 if it's false and in 1 if it's true. And the way we wrote this laser code here, it's saying, let's see, in 0 is for the G code, right? And then in 1 is for PyVCP. So that way, if you're in the middle of running a G code program, then the other pin goes, and this pin goes true, and then you select the wrong thing, right? It's backwards from what it's supposed to be. So I guess there's two ways of fixing that. One would be by just swapping the pins around, right? So saying this motion digital out, we're going to swap this one then to 1 and swap the other one to 0, right? That's one option. The other option is I know that there is an out component as well, or not an out, a not. Man, not, yes. And this is another HAL component that just inverts a pin. So if we were to come back to, where were we? In 99.postgui, and then we did like a load RT out, add F, let's see, what's the function name it gives? Just, no, not out, not. What am I thinking? Jesus. It's late and I'm tired. If I did load RT not, and then add F not.0, we could then stick this not in between here, right? So we have this going to not.0.in, and then have a net running program not, and then that's from not.0.out to the selection. I think that'd work. At least that's the sketch. That's roughly about what you would do. Now I've already gone and made this full series here, and by the time I edit this code, edit this video, this code will already be published up on GitHub. So I'm not going to go and change the tutorial series I've already put together, but I would say for you, it's probably actually pretty good practice if you're to come back and try and make this work, or to disable one method of running the relay while you're in a different mode, right? While running a program or not. So yeah, I'd say there's your homework for the next class. So yeah, if this video is helpful, you're welcome to subscribe because there are more like it coming out soon. More importantly, please do share this series with any other machinists that you know, because LinuxCNC information, it can be very hard to come by. The documentation is great, but it's also very dense, and having someone there to walk you through it step by step, yeah, I wish I had that. And that's why I'm here making these videos, right? To try and help other people out. And if you have any questions on the content here, just feel free to drop a question down below in the comments. And as long as you ask good questions, I'll try and give you a good answer back. And if at any point in the future I have a way for you to support this channel, either by me selling CNC parts or t-shirts or whatever, links for that will also be down below. Anyway, now we're on to part 5, where I explain how I got the Xbox controller working with my CNC machine, and then how we tie that into HAL. So until then, peace.